Hey everybody! This week we're
Making mistakes.
making mistakes this week. We're going to do top 10 most common mistakes that we see with first-time Origin users. We're going to go through what they are, how to fix them. So hopefully we can avoid them.
You're going to learn a couple things with us. We're going to teach a couple things. Enjoy the show.
Yeah, enjoy your show. Hello everybody and welcome to Shaper Sessions. My name is Jake.
And I'm Sean.
And today we're doing the top 10 most common mistakes that we've seen that people make with Origin.
To hopefully save you a little bit of time when you get to it.
Truth is, we're all going to make mistakes, especially when we're learning new tools. We've recently leaned into making mistakes live because they do happen. And we learn great things when we learn how to fix them. So we're going for it. Let's go ahead and hop into the overhead real quick just to show you what we got going on. We're going to do some stuff on Workstation when we talk about gridding, but we're also going to do a lot of tape setups, tape board setups, and kind of go over what could get in your way in a setup like that.
Totally.
Get ahead of it.
All right. Let's just jump into it.
First one's you.
Number one. All right. So I'm going to bring this over here. And we're going to talk tape layout real quick. So I have a couple boards here. And what you're going to notice is they are not the same thickness. So if I bring this up here, this one's about an 1/8 of an inch thicker than this one is here. So let's assume we wanted to make a workspace out of this, and Jake's going to come over here and drive it. We want to make sure that we don't get what we like to call low accuracy scan errors. And we're going to kind of explain what that means. There's a couple different ways this can happen. But in general, if you keep your tape on a single flat surface, really won't have any problems. But if you're trying to, you don't have enough material and you're trying to build up more tape room so you can cut something, you really want to make sure you have the same thickness material, because Origin's camera system is going to look at that tape and try to understand the world, and it's really looking for a flat area. So we're going to show you what happens if you scan something with two different height tapes, so we can walk through this. So we'll jump over to the Origin cam. We're going to go into new scan mode and start a scan. And here we are just moving around like normal. And then we just need to save it. And what we're going to see is a little pop-up here. It's going to say on screen, we've detected accuracy issues in your scan that could decrease your cut quality. It's likely that you have shaper tape on different planes or your material is warped. And so the message will tell you kind of pretty much everything. There's also a little more info button here if you want to go research some more info on the website. There's a bunch of info about this. But in general, flat surfaces, you should never really see this. Now, what does this mean? You'll notice here the default option for the green is to rescan. And the idea here is, hey, rectify the situation and then rescan so you get in a good place. And if you hit that green button, you'll just go right back into scan mode and everything's gravy. And you can try to keep scanning. But if you have a material or something that's flat, or you really don't have an option to not use it, you might have to open it anyways. And there's a couple little key details here before we do this option, because we don't want to keep you from doing it. There are times where it is important. But if you were to click open anyways, you'll notice it's just going to load that workspace, just like if you would have saved it, no problem. Now, moving around in the world, you might see this happen. Tape movement detected. We're going to talk about that in a second. But basically, if you're going to use a workspace that has a low accuracy, I would just make sure that whatever you put your file down, I would do an error cut and drive it around, because you may see some erratic motion on the spindle. You may see a retraction that happens every time you get to a certain spot. This low accuracy thing does create a lot of issues for the system, and it's how we track the correction mechanism. So if you load a low accuracy workspace, you're going to essentially end up having kind of a possible bad scenario later. But let's say you're working on a big floor, it's a little curved, you can't change it. So like there are times where you might need to load it, but in general, for this one, we're going to remove this kind of top thing that's not the same thickness, and maybe we would just rescan this. That would be the ideal way. Go back into scan mode, scan that, hit finish, and then now we will be back to the normal space. So if you have a low accuracy scan message, try to get back to a world that's flat, not curved, not multiple tape planes, and then hopefully you'll be good.
Places I feel like I see this most are people cutting a piece of plywood like this size and putting tape on their bench.
Yep.
2 different planes. And then also slab work.
Slab's
not
always
perfectly flat.
Yep.
Or full plywood sheet, especially like 1/2 inch or something, and it's under supported.
Yep.
So sitting on sawhorses or something, the whole thing is bowing.
You'd be surprised. The vision system on Origin is very accurate, and even slight bows or slight steps will cause that thing to happen. It's not impossible to use those workspaces, but ideally, rescan, figure out what's wrong with it, flatten it, move tape to an area that is flat, try to figure out if you can face a different direction. And then, yeah, should be good.
Yeah.
All right. That's one.
All right, another warning that you might see come up on screen is tape movement error. So let's go ahead and make that happen.
Pull this up. I'll grab this, and we'll place this with our other little demo right here.
It's not helping us that our...
I'm just going to leave it here.
Yeah. Pick an MFT. Okay. So this is more likely to happen in a world where we're using a tape board, which this is a totally sanctioned operation. The key is we want to make sure these two things do not move relative to each other. If they do, we'll see this. So I'm going to go ahead and start a new scan. There we go. Let's say I'm happily cutting along and something knocks my tape board or my double-sided tape or whatever. It's not properly secured. That message is going to come up. So it's kind of making sure, hey, we've lost the ground truth that is our scan. Now things are never going to be perfectly aligned. So if this happens to you, it's kind of a rescan. Make sure it's properly secured and rescan fresh from that point.
Yeah, if you haven't started cutting anything, I would just not start.
Yeah. Get
it fixed, and then go back and do a new scan.
Yeah.
But you may be in the middle of a project, and this happens.
So if that's the case, take it completely out. Make sure that it's properly secured. A lot of double-sided tape, clamps, and add to scan.
Yeah, and what I would suggest for that is for this upper piece, I would take this tape off if we go to the top cam.
Yeah.
Take this tape, replace it with new tape, because otherwise it's going to be very confused. If we go to the Origin cam here, you're going to see when I move this tape around, it's actually recomputing the position and doing all sorts of funky stuff. And so, if your tape moves, you're going to be in a bad space. And you really need to figure out what moved so that you can then fix the situation. So a lot of times what I'll do, I'll actually, okay, so we get our tape movement error here. I'll put my hand over a couple areas. So for instance, I'll put it over this top area. And after a second, if you kind of move Origin around, you could kind of see, okay, cool, my tape error message is gone. So that means the top part is the problem, not the bottom. And then you could, replace that tape, put it back on, and then add the scan from the tape that hasn't moved. But yeah, like Jake said, main point, if you're using two different pieces with tape on them, make sure they're really clamped down or double-sided and clamped. I always go the extra mile when I'm working with two different pieces because they get loose easy sometimes.
Yeah. The only other time I've seen that error is if I have a really dusty work surface and my tape didn't stick in the first place. Or really, sometimes it peels up in the corner. Certain materials like HDPE.
Yep.
Nothing likes to stick to HDPE.
True.
So if you have a piece that's peeling up and you think, I'm just going to stick it back down, if you didn't stick it back down exactly where it came from, you might get that warning. So it's best to remove it completely.
Yeah, here's a good example of it if we go to the top camera. So I've already gotten rid of this. Our tape movement's gone. But if I take this little piece here in the middle and then just kind of pick it up and put it back down over here, we're going to see the tape movement detected error on screen. Now, in this case, similar to how I solved it with the other one, I'm going to put my fingers over specific pieces of tape, or maybe half at a time, and wait until that message goes away. Then I can say, okay, cool. It happens to be wherever I'm covering. That's where the error is. And then, yep, okay, now the tape movement's back. So something in this area is causing the issue. Then I might start, covering up different pieces. And then when you find out which part's doing it, I would just rip that part off, add the scan, and then you won't have any problem.
Nice.
Nice.
Good. As far as tape peeling up, that won't be an issue as long as your material is relatively dust-free. And
yeah. And what even another good little tip is just running Origin over the base of your tape after you've applied it.
There you go.
Gives it a good little extra amount of
it's a burnish.
Yeah, a little bit. So, yeah, nice,
cool.
Okay,
Flying through.
Yeah, we are. All right, so take this over here for a second, Jake. I'm gonna go ahead and do what we talked about, actually taping this down properly, just so we can use this as a demo piece. And then we'll need to do a new scan. There's one.
So what's this mistake?
Yeah, so this mistake is actually, thank you for reminding me, it's in my head, but it's not out in the world yet. This mistake is, if we come to the top camera, when you first get Origin and you're figuring out how to put files places, you need to learn that the image that you see on the screen is close but not perfect. So what I mean by that is if we do a new scan over here, and if we do a new scan, okay, and you're going to notice I've drawn kind of an area where I want to put this file. And if we go to the Origin screen, this is the file I want to put in. It's just a little circle. And if you kind of look on the screen, I've kind of drawn out, cool, I want this like 4.5 inches over here and 2 3/4 here. And I kind of drew a circle so that I can put it in there. If I go to import that file, and I find it right here. If I try to zoom in and line up that circle with the circle I've drawn, even if I get it kind of perfectly there, that image that we see on camera and the world in the real world is going to be close but not perfect. And so if I don't care that it's exactly perfect, I can kind of place it like this, cut it. I would say it's going to be anywhere from on the money to 1/16 to 1/8 of an inch off in any direction, depending on how you scanned and a bunch of other factors. But it's not going to give you perfect placement. It's not going to give me 4.5 by 2 3/4. Yeah. And so the key here is that if you're assuming the position needs to be perfect, do not trust the image. And instead, we need to trust the grid. And we have a bunch of videos and sessions where we talk about how to grid different types of materials, where maybe we want it on the corner of a piece of material, or maybe we want it on the edge of a piece of material, or maybe we want it on the surface of a piece of material. So there's a bunch of different things to learn about the grid. But the key factor is, if you need perfect placement, you need to be using the grid, because the image is only close. It's not perfect. And so I think that's kind of one of the things that everybody learns. And some people learn it the hard way because they try using the image a couple times and it's perfect, and then they go to a point where, they're installing something like a sauce hinge that needs to be perfect alignment and position.
And parallel to your edge. And
all these things. And it's not going to be that way with the image. You might get lucky sometimes, but if we need to do that, we need to use the grid. And I think that is going to bring us into tip number 4, Jake.
Which is gridding issues.
Gridding issues. So let's go over to Jake, and he can talk about this for a second.
I feel like I have had this conversation a couple times with people. I've made a grid, but it looks off. Now, there's a certain degree of, okay,
what we just talked about.
What you just talked about. We're scanning this thing. It has a little bit of a perspective. We can't 1,000% trust the image. We trust the grid. But sometimes it looks obviously off. Like there is a 1/8 of an inch gap, oddly, exactly an 1/8 of an inch gap from my grid to my image. 9 times out of 10, it is because we have not changed our probe size when we started the grid. So I'll show you what that looks like. I'm going to swap to, we always try to encourage best practices here, and best practice for gridding is to use the engraving bit chucked up backwards as a solid 1/4 inch probe.
Yeah, it's like perfect on the money.
Yeah. Throw that in there. And okay. So I have my leg stock chucked up here. I'll go ahead and create a grid. And we'll do a front side grid. Those 2 points there and my 3rd point over here. Now I could feel how wrong that felt. And I just zipped through it like that. That looks oddly consistent and specific. Well, I had a 1/4 inch probe in there, but it thought that my probe was 1/8 of an inch. So I'm going to be 1/8 of an inch off on all edges. So if we go ahead and change that, lower my bit back down. Now we're, lower it a little bit more. There we go. Now we're contacting that edge. And in some areas, the image might not be perfect, but it's a lot closer than it was before.
Origin will try its best to warn you. So like when you make a new grid, if you don't do anything, it'll pop down a little thing that says, hey, check your bit size. Make sure it's correct.
Yeah.
But if you're rushing through it, sometimes you'll miss that. So just make sure that bit diameter represents the size of the probe you're using, because otherwise everything will be off by that difference.
Yeah.
So that's a pretty big one.
Sometimes you're off a whole 1/4 of an inch.
Yeah.
Here's most likely why. We're going to start a new grid.
Do a top grid.
I'm going to do a backside grid, which we always love to do when we're cutting tenons.
Now, that was the key point there, and you can already kind of see it on screen. The line is on the wrong side of the bits, and so you have to kind of toggle that to make sure you hit the right area. Otherwise, you're going to get a full bit diameter off.
Yeah, exactly. So we do that by just hitting this edge button down here at the bottom. And you can cycle through. We can even use the center of the bit if we want to use the pointy end of the engraving bit.
Yep.
Call that a center line grid. So cycle through to our bottom side, contact, contact, and contact.
Boom.
There we go.
So that's a good one. That happens a lot to people. I've done it. I did it the other day. I just forgot when I was thinking. I actually got all the way through the gridding process because I wasn't paying attention. Cut my tenon, and it was off by like the whole front of the tenon didn't get cut. And I was like, what is going on? Oh, I accidentally forgot to toggle the other side.
Yeah.
Should have known.
Yeah, it's funny. Back in the day, you could only make a front left grid.
Yeah, there was until one of the, like, I don't even remember, maybe Castro release, you could only make a front left corner grid. That was the only one possible. And then we redid the whole grid system so that you can essentially, the way I would best like to describe it is you can grid any part of a picture frame on the inside or the outside. Any corner, inside corner, outside corner.
And now even beyond that, you can probe any part of a picture frame. You can probe any part of a circle.
Yeah, there's
a circle probe.
There's like a really, if we come over here, there's like a really cool grid technique that Jake talked about with the center line, where essentially you draw a X and a Y with an interest point, and then you use the engraving bit to lower down the center of the point, and you look through the hole where Origin cuts, and you just take center line grids on, 2 pieces here, and that gives you this direction. And then the third point is just on this Y, and then you have this perfect on-center grid for visual drawings.
Yeah.
And then that would align the shapes perfectly to, some drawing on a surface. So there's
this
a whole grid video that's like 20 minutes long about all the different types. So if you aren't familiar with gridding, definitely go check that out. There's a lot to learn.
When in doubt, grit it out.
I like it.
It's a safety net.
Is that that's a t-shirt,
That's
Jake.
a t-shirt. I got so many t-shirts I wanted to make. The last thing I will say about grading issues is don't push your probe against your piece with all your might. We're really just making contact with the probe and our material, and that's enough.
Yeah, you don't want to be pushing crazy hard against it. Just a light touch, click. Yeah. Everything else is good.
And that's it.
Nice. Okay. Tip number 5 coming up. Okay, this is a classic shape of origin problem. My bit will not fit in the file I'm trying to cut, therefore there's no toolpath being shown. So let me show you what I mean by that. I'm going to bring this over here, and I'm just going to click back to that workspace we had, and I'll delete this file for a second. Okay, so let's say I have a 1/4 inch bit in my origin, and I need to cut an 1/8 inch hole. So I'm going to just make a circle real quick that's 1/8 of an inch, and I'll place it here. So if I go to cut mode and I tell it I have a 1/4 inch bit, everything looks good. I have my depth set properly. If I hover over that shape, you're going to see that it gets highlighted, but the cut button never appears down here. And if I click the green button, nothing happens. It won't cut, et cetera, et cetera. Now, there's nothing on Origin that tells you right now that this doesn't work, but by not having the cut button, you can start to deduce a couple of things. One, you need to check that the offset and the bit diameter will be able to fit in that hole. And so if we made that bit diameter, let's say we had a small bit, 0.0625. Now we would see the cut button show up and we would see the toolpath show up. And so this is one easy way to just quickly check, oh, okay, my bit will not fit in that hole. I need to change my things. So that's kind of a one. The kind of first check's always going to be, is my bit size able to fit in the shape that I want? Now, if I change this to an 1/8 inch, what you're going to notice is it's still able to cut. The 1/8 inch hole can be cut by an 1/8 inch diameter cut. Sometimes this works, sometimes it doesn't. Depends on where your file's made. It depends on how many, where it's made sometimes can affect this. Now, let's assume, let's just say I had a 0.12 inch bit. Okay, oh, a little more, 0.13 is what I wanted, not lower. Okay, so now I have a 0.13 inch bit with a 0.12 inch 5 hole. Now, I could obviously make the shape bigger in my design file so that it fits my bit, but in a pinch, you can also change the offset. So if we change our offset 0.005 negative, then we're going to see that cut button show up, and essentially we're growing that hole by a little tiny bit. And so this is a nice trick. Sometimes you'll have a file. A lot of times, like things like slots or rectangles. Let's say we had a, let's see if it will work.
Like a dado?
Yeah, like a dado. Like let's say we had a 0.125 inch dado, and it was, 10 inches wide. Okay, so I'm going to put that here. If I go to try to cut it, let's change this back to 0. Yeah, so that's a 1.25 inch, but I have a bit that's a little bit bigger. It won't fit. I can just kind of try to work that offset just ever so slightly until I get my cut. That's only going to open that up 5 thousandths bigger than it says, but sometimes that's enough to continue through that cut. There's a couple different ways to do it. Get a smaller bit is always a key one, but sometimes you don't have a smaller bit.
Yeah.
And sometimes you just need to get it done. So that's kind of a common one that people find is like, I don't know why this is not giving me the cut button. Hopefully you won't run into that one yourself.
I got one more to add to it. I'm just going to make a weird shape.
Love it.
And change it to a pocket. So especially with pocket, because pockets have a built-in, we'll do a 1/4 inch bit to make it a little more obvious. Pockets have a built-in buffer around them when you're using Origin manually, and that's intentional. We want to make sure that when you're hogging through material, you don't accidentally cut into the inside edge of your shape. Sometimes it can be confusing because you're like, whoa, I need to cut this business over here, but I can't because I can't fit in there with a 1/4 inch bit and that buffer.
Yep.
So maybe I swap down to 1/8 of an inch. Okay, I can get in there and here, but not down here. At this point, if I'm really careful, I've gone in and adjusted that negative offset to, that's too much, 0.02, and just slowly started taking that buffer away. But it's, depending on the shape, it'll only get you so far.
Yeah.
That buffer is there to protect you, but if you're careful in certain areas, you're good to go.
Nice. All right, so that's 5 of the 10. But maybe let's take a little break, go to break time, and then we'll come back for the last 5.
Let's bring that question up. We got today is, what is your favorite tool in the shop besides Origin? Now that may sound conceited, but we wanted to make sure. We want to know what your go-to thing is.
We know most people's favorite tool is Origin.
I mean, it's mine, but I don't want to assume it's everybody's.
It's true. It's true. But yeah, what other tools make you happy in the shop?
Yeah.
Probably all of them. That's where we're going to get most answers.
Yeah. Just the shop as a tool.
All right. And remember, that poll gets you into...
Yes. You must answer that poll in order to enter your name into the wheel to get the winnings for the giveaways at the end of the show.
Nice.
All right. Let's go ahead and hop over to Woodware has sent us in a shop tour today. Thank you so much for sending that in. I believe we have it up and ready to show. Let's do it.
Hello and welcome to Woodware. Yeah, and I think one thing you can say is Woodware, it's wood everywhere. Let's give you a quick overview of the place here. Corner where we do most of the fastening, drill press, some mechanical. Then we have our saw table molder. Here we are. That's the part that goes on top. There's the driver. And it has a moving table which does exactly 2 meters because I'm limited in space. 2 meters is also the distance between the saw blade and the bandsaw. The bandsaw is a N4400. I thought I was going to use this a lot, as with the molder, which I don't. What I do use extensively is this Festool Capex with the left extension, and there we have the right extension. And we have a plano clamping system which I use to make tabletops and anything that has to be flat. It has a surface of 2 meters by 1 meter. I have a thickness planer jointer from Hammer. I also have a wall of Festool stuff. Yeah, well, evidently I like Festool. I even worked for the company for 2 years. I have an MFT with a CMS, which is currently set up for as a molder, I think you call it. The workbench, that's the first thing I made once I was officially a cabinet maker. So here we have my Shaper Origin caddy. As you can see, this is workstation room. Here we have my Z-sled, drawers from IKEA, very good quality for no money. The vacuum cleaner, plate still has to be unpacked. MFT boards for working on this side, and of course Shaper Origin in his box with a lock. This is the latest project I'm working on. It's a walnut case for a Fender Concert 2 for those that are interested. I think that wraps it about it. And of course, the obligatory coffee and computer stand. That's what we have.
Wood where?
That was awesome. That is so
You're
much.
supposed to say wood everywhere.
wood everywhere. I'm sorry. Thank you so much for sending that in. I love that in a small space you still managed to get a sliding panel saw.
Yeah, I mean,
What's our excuse?
I know we really missed out. We you
Lots
know,
of saw.
I want a panel saw in my house now.
And also we also have the hammer A3 joiner and planer.
Yeah,
but we
we-
got the joiner and planer
did.
separately, which
We need a split.
I love it. It's so good. I
I
can dial things in with that.
Yeah, I really like having two different ones. I also that Clearview dust collector
Why
setup.
buy a dust collector where you can just make your own?
Oh, I know. I know.
Very
Anyways,
cool.
thank you for sending in that shop tour. We are getting a little low on shop tours.
are.
So if you got one, remember, a couple minutes, landscape, not vertical, landscape this way, 2 to 3 minutes,
Narrated.
narrated, tell us some fun stuff, make a joke or two, you know?
And send it to sessions@shapertools.com. If you have sent one via a iCloud link and you haven't seen it been shown, it's probably because the iCloud link expired. And
Yeah, or respond to that email and say, hey, Sean and Jake,
where's
where's my shop tour?
Yeah.
We might have just missed it.
Yeah.
So we'd be glad to show it. Just send it again so we can get that file from you.
All right. Back into the hot tips. I see this a lot from people that are coming out of using big, beefy 16 horsepower routers, and they're hanging on to these things for dear life, and they do the same thing to Origin. We call it death gripping the tool. They're just white knuckling it, acting like it's going to jump away from them at any point. And the moment that I can see white knuckles, I know they're probably seeing jerky cuts, and they're just
Probably bad cut quality in
bad
general.
cut quality
Yeah.
and under tension the entire time they're cutting. Take a breath. Origin is all about smooth input, great output.
Yep.
So often I personally love to sit when I cut, but it depends on the application. Light hands. I even keep the sides of my hands kind of planted on my workspace, especially during those tight operations when I'm doing text or coming around the edge of a sauce hinge or something. The sides of my hands are planted, and I'm driving with kind of just my fingers.
Yeah.
For any kind of long sweeping cuts, you're trying to do an arch for a doorway or the edge of a table. Lock those arms into your side and use your whole body to bring that tool across. That's really it.
Those are the two main ones, I think. I think the third one may be a light amount of down pressure is good. You don't need to put all
Consistent.
your weight on it, but some consistent, especially if you're pocketing out an area and you want the bottom to be perfectly flat, getting the right weight down is good. And the weight is actually going to help. If you're ever cutting and you feel like it's kind of like jerking around a little bit of down pressure might keep that from happening. I mean, you may be taking too aggressive of a cut in the first place, but some down pressure can help increase friction that'll keep it from sliding around. So yeah, plant your hands on the material. Don't grip it too hard. Keep those elbows tucked.
Yeah.
Keep your core tucked if you're making those big, long cuts.
It's all right here.
It's all in the core.
I'll even say sometimes I use workstation or the side of my bench or whatever it is as kind of a guide. I have my outriggers.
If you ever watch someone who knows how to use a plunge router really well, they don't hold the plunge router in the air. They're always holding it and they're planting, and we're kind of suggesting the same type of action.
Yeah.
Nice. Cool. Okay. On to tip number 7. And this is just a classic one, too. Forgetting to lock the spindle. And I don't know if we have a good camera. Maybe the side cam over here. If you don't lock this thing, then the spindle is going to move up and down while you're cutting, while you're Z-touching. And so I have a pretty good tip for this. And it all comes down to a checklist, a little mental checklist. So anytime you change the bit, what I like to do is put my spindle in. A lot of people will go plug that in first. Don't do that. Jake, don't do that. Do not plug this in until you've locked down the screw. Because if you ever are in the shop, you know how you get interrupted, you stop thinking about stuff, something happens, you turn around for a second, then you try to figure out where you were. If you ever see that spindle unplugged, that might mean that it's not locked. And so I can check it, and typically I'll just do it anyways. And then after I put that in, now my mental checklist says if it's plugged in, I don't have to think about it because every time I always lock it before I plug it in.
That's a good one.
That's my little tip.
Let's see what it looks like, or classic symptoms of not having your spindle locked.
Yep.
First place it would show up is when we do a Z-touch. If we go ahead and hit that side camera, I'm Z-touching, and it's just going. Z-touch failed. Not sure if we can get a better look at that, but I'll do it again.
Yeah, you'll see that
right.
The metal show up. Okay.
Next thing, if you somehow manage to get past that and you start a cut while the spindle is not locked, it's gonna feel different.
And
have you ever done that?
Oh yeah, for
Okay.
sure. I mean, what you'll end up finding is your cuts have a lot of variance and depth because depending on how much down cut and how much side cut, it can force it up. Even the type of bit you're using can affect that.
Mm-hmm.
So if you see some like different in height, yeah, check that spindle, make sure it's locked.
Chatter in the cut too.
Yep.
Because there's a lot more vibration happening, and it's not secured. It's gonna sound different, like a heavier.
I will say, if you take my checklist,
That won't happen.
I don't think I've had it happen in years.
It's good.
Maybe-
Do whatever you can to avoid that because it's
Yeah.
definitely.
It's just even mentally like, what is going on?
Yeah. So I will follow that tip because I don't do that, but I will now.
You always lock it afterwards.
Yes.
Nice. Okay, well, that's tip number 7. Jake, on to your tip number 8.
We see this often when people are just getting started. A lot of burned material or burned bits, especially people that haven't used Origin before. Even if they have a lot of experience with routers, I'll see people be like in the middle of a cut and they'll just stop moving anywhere. And at that point, you have a bit that's just spinning at high RPM right up against material, building up friction, more and more friction. That's how we start small fires. So tip number 1 in this is just always be moving, always be cutting. And if you stop or need to pause or are done, don't forget to hit the red button to retract.
Yeah, you can always continue where you left off. No big deal. But you don't really want to just sit there while you turn around and listen to someone tell you a story.
Yeah.
And then come back and continue. Just hit that red button, come up, hear that great story, and then move on with your day.
The other thing we see is people crank the spindle speed all the way up, but they're still moving in the cut relatively slow. So we're still just building up that friction. We're not really cruising through the material fast enough to dissipate that heat. And we start seeing burnt bits, which here are a couple examples. Get a nice chocolatey brown to black.
Yeah, pretty classic bad bit situation.
And this is deep. This is like the tempering is changing in the bit. These have gotten really hot. But often there's especially if you're cutting a lot of ply or MDF, there's stuff that starts to get caked on there. And the longer you leave that caked on and burnt on, if you continue cutting with it, it just gets worse and worse. So, shameless plug number 1, get yourself a bit washer. They're fantastic, and you don't even have to think about it. You got your fluid in there, toss your bits in there, turn it on for a couple of minutes, continue on. And by the time you hear a ding, it has, if the special solution has not gotten all of the resin and crud off, then the ultrasonic action has gotten in there and like chipped it away. Not chipped, really gotten underneath it and loosened it.
Yeah, I mean, keeping bits clean is a big thing, especially if you want that bit to last a long time.
Yeah.
If you with proper speeds and usage, bits will last a very long time, but it doesn't take long for them to go bad if you are lingering or whatnot. Couple other ones I'd add. Don't start with spindle speed 6. You don't need spindle speed 6, rarely ever.
I don't use. Do you use spindle speed 6?
There's very few situations where I use 6. 5 to 4 is my default, like 4.5 probably, and that's when I drive origin by hand with most materials. But when I'm using bench pilot, I mean, I'm going down to 2 and 3 a lot of times because one of the things that's going to end up happening is it's going to feel better if you turn the speed up when you're driving manually, and if you feel it's like a little hard, you're going to crank that speed up. Oh, it feels better, but now you're cutting too fast. You're basically not making enough chips to release the heat. You're just building up heat. It's going to feel nice, but you got to find that right balance between feels good and doesn't burn up your bit.
You're creating sawdust versus chips.
Correct. So, yeah.
And then as you get more and more confident with the tool, you feel yourself starting to move through cuts quicker, start creeping up in spindle speed. But again, if you're doing it manually, very rarely do you ever go to 6. I think the only times I've ever used 6 are when I am using the 5mm O-flute and cruising through plywood.
Yeah.
And like I have a generous roughing
Half-inch
offset.
cuts.
1/2 inch to 3/4 inch cuts. And I'm trying to go through, like I'm moving pretty quick.
Yeah.
And I have an offset that's like 0.06 just in case.
Yeah.
But that's really pushing it. But that's really the only time I would.
The only other time you could probably use 6 is when your bit is beyond toasted and it's dead, and you just need to keep
Start
it
a
going. Turn it up to 6 and keep going. Sometimes it'll get you through a little bit longer, but you know, you're like with these, you would need to be running very fast for it to do anything, you know.
And you know, I'm like, I don't know if these have gone too far, or we could bring these back. We might have they get soft if they get too hot. Carbide gets soft, and you start to lose that edge. So clean it before it gets to that point.
Nice.
Yeah.
Okay. Next up, tip number 9. All right, I'm gonna peel this tape off for a second to get ready for this one, just because we don't need it anymore. Because tip number 9 is gonna involve plate. Okay, so here we have plate. There's a couple of key things that you don't want to do on the plate or workstation, kind of either one. You don't want to cut into them. And that is tip number 8, how to keep from cutting into your jigs. Okay, so with a couple things, hold on, I lost my microphone pack on the floor. Okay, here we go. So there's a couple of key parts. I mean, obviously you don't want to cut into any of this, but there's 2 key pieces on plate that move. The reticle, which is here, and then also the fence, which is here. And so there's a couple things. Obviously, if you're, let's say we were going back to this kind of example here where we want to cut this out. We're going to, if you haven't seen plate, there's a bunch of ability to register, pieces directly to drawings and X marks the spots on your part. But if you forget to put that up and then you bring origin over and go to cut, you're going to cut right into this thing. So before I cut, when I'm on plate, I'm always, let's say if I have origin here, before I go to cut, I'm just going to move plate out of the way. Oh yeah, take a quick look. Oh yeah, I forgot to do that. Okay, now I can come back and cut. So anytime I'm right before I'm making a cut, I'm moving origin out of the way just to check that nothing's in the way. Okay, so that's one part of it.
What do you think about this idea? I've
Yeah,
seen
go
somebody do this. They deploy the fence and the reticle for their first initial scan.
Yes.
So that plate and so that's
Totally.
in the scan, and you see it every time. And so you're visually reminded. Oop,
Yep. And a lot of times I'll even, in the file on origin, I'll write right in the bottom, check that this isn't in the way, just as a visual reminder. In general, when you lower the fence down here, you're actually kind of increasing the area of this big cutout or reducing the area by a little bit. And so in general, I like to leave it out if I'm cutting something like this because it's going to keep plate from moving this way, even though the grippy tape underneath will kind of help. I always like to have one face that's kind of like up against it. But there's a lot of hinges, I don't know if we have any here, that require you to cut off the edge. And if you forget to click this button, you're going to cut into this bottom bar. So like typically for the files that I have to cut off, I'll put a note in the UI. Sometimes I'll just even do it with, I'll just do it with the on text tool. So if we go to design, create text, and then I'll write check fence. And I'll put it right near the bottom. So that way, anytime I'm in this file, when I'm here, I'm like, oh yeah, okay, I need to check the fence. And you can even turn all these into guides by changing them here. And then they'll show up blue. You can't actually cut them, but it's like a good reminder to make sure you don't cut into that fence.
nice.
Okay, so that's plate. We also have a similar problem on workstation. So Jake's going to move this file over a little bit here. This is a classic problem. And you know what? Before we even get into this, obviously you don't want to cut into these things. But if you do, it's mainly okay. Normally,
you're
it's
not alone.
okay. I've cut into mine many times. It's going to be fine.
It's a rite of passage.
It kind of feels good once you're like a year into it and you're like, yeah, that one was from that and that one was from this. So it's okay. There's only a few places like these reticles, and we have spare parts that can be replaced quite easily.
Yeah.
But yeah, don't fret. I cut all the way through the dominoes on my plate on accident. And
Shallow, right? Not
yeah,
like
shallow,
okay.
pretty shallow. But I lost all these dominoes here. But there's enough dominoes for it to
That's
to
why
still
there's
work.
extra dominoes on
And,
there.
we made sure that one mistake doesn't cost you the plate.
Yeah.
So okay, with that, let's go over to workstation.
So, a couple areas that you can accidentally cut into on workstation. We have the clamping face. Now, in this current setup, I have the clamping face in its highest position. But if I'm cutting a tenon, I'm going to come right around and start cutting into that aluminum, which is why we designed it so these two cam screws allow us to drop it down to 3 different heights, tighten it back up, and now our piece has plenty of space behind it so that when we're cutting our tenon, we're not cutting into workstation's clamping face. We have space to sneak around.
Yeah. And you can just adjust that face up like you saw in a couple seconds. So
Yeah.
Feel free to move it up and down for whatever project you're working on. So
I believe it's 25 millimeters and 50 millimeters.
I believe so. I normally think of it as 1 inch,
1
and
inch,
2
2
inch.
inch. That's how I think about it too.
Somebody's like, that is not half.
That's not how that
not
goes.
50 millimeters. I really don't know.
That math ain't happening.
But yes, you can always just check it. A lot of times what I'll do is pull my calipers behind it and just make sure I have clearance for whatever bit I'm in depth I'm cutting.
Yeah.
So yeah.
The only other place I see on Workstation where we get the occasional whoopsie is on the support bar.
That was probably me.
Yeah,
That's a classic Sean move.
and that happens from when we're just getting a little too close to our piece. And again, we're cutting all the way around this thing, and we forget that.
Yep.
Oh, we're just going to shave off a little aluminum.
Yeah, and you know, all those parts are aluminum, so you know, you can cut through them. Won't feel great, but it's not going to feel terrible.
Just add a little.
If
sparkle to
you're
your
ever
work.
cutting and you're like, wow, it just got interestingly a little harder, just maybe take a pause.
Yeah.
Retract, and then check out your new shelf with a personalized touch.
Yep. It happens. It is okay.
Okay, so that's tip number 8. Try not to cut in your jigs. All right, last tip, Jake. All yours.
Second to last. Oh, all right.
Yeah, number 10.
Number 10 is, I saw this recently, trying to cut too deep with a bit that doesn't have long enough cutting flutes. So, great example of this is our standard 1/8 inch bit that comes with Origin. It's one of my favorite bits. If you look at the profile of it, we have about a 1/2 inch of cutting flute length before it starts to kind of taper out. Now, this taper is great because it actually adds to the rigidity of the bit considerably. However, if I try to cut deeper than a 1/2 inch, let's say I'm cutting 5/8,
3/4.
3/4, I'm going to start seeing and feeling essentially like rubbing because there's no cutting flutes at that tapered section. So I'm going to feel a lot of resistance if I'm going that deep, and I'll look at the cut afterwards. It's basically built up friction of just carbide rubbing against wood. So a
Yeah,
little
it'll
bit
be
of a
burned up at the top a lot of times.
burnt or
Yep.
just like burnished really bad, and it
Yep.
feels like I'm pushing against something versus cutting through something. So that's one tip. In Origin land, we care a lot more about cutting flute length than overall length of bits. So a couple of bits to show. Our 8mm bit, another one of my favorites. The cutting flute length is 35 millimeters, but we can actually go a little bit deeper safely as long as we're not doing it in a single finish pass. So that's just something to consider as well. Our longest bit that we sell is the 1/4 inch O flute. Is this it? No. I swear I had this one fully outfitted. There it is. 1/4 inch by 1.5 inch O flute. So that's going to be our longest one. This is the one I reach for when we're cutting foam.
Yep.
Especially. Gets those chips up and out, but also allows me to cut all the way through those foam blocks. Let's see.
Okay, one thing I hadn't thought about,
Mm-hmm.
but this reminded me, is that, okay, let me think how to explain this because we didn't plan this. Okay, so when you put that bit into your spindle, it's going to be out of the spindle a certain amount, right? And so there's what Jake's talking about, which is how mechanically far can this bit cut? And that's one thing that you definitely need to pay attention to. Every bit's going to be a little different. But there's also an issue of when you do a Z-touch, how far away your bit is from the material is going to limit your maximum depth as well. And so maybe we can show this, like if you push that one in, you know, kind of pretty far down, but not to where the flutes start, and lock that in. When we put that into Origin and do a Z-touch, we're going to get limited by where we put that bit in there. And I'll show you what I mean. It'll be a little easier when we get it on screen here.
Too many spindles.
All right, so if we
Watch
put
me.
this in.
Watch me.
Oh, look at Jake.
Look at that.
Learn it. He's
learn
really
too.
learning. That's tip number 7, if you forgot.
Always be learning.
Yeah. Okay, so if we look at the bit cam real quick, underneath, you can see we're not actually down at the far end of the material. Like there is some space between the bottom of the bit and our material. So if we do a Z-touch, and then we try to set our bit to 1.6 inches or 1.5 inches, we're going to get a message that says cut depth is too large, defaulting to maximum cut. And you can see here the screen says 1.433. And that's because there is, some 0.25 inches of space between the bit and the material. So if you want to cut that as deep as possible, you need that bit to kind of be as low as possible. So you're going to either need to get a different bit that has more reach, or you can kind of take that bit and cheat it out a little bit. Now, obviously, you want to be careful and be thoughtful about how much you're cheating it out. You don't want just the tiny end of the bit to be in there, but you can kind of pull it out some, check and make sure that it's below. And what I like to do is I like to lift the spindle. Well, we could put it in, Jake, and then just lift it up and tighten it so it's right above the material. So we don't need to figure out the distance here. It can be chucked up out of the spindle lock just ever so slightly. So I just lift it up and I just tighten it down, and then that way you can kind of get it right above the material without having to fiddle with it in the spindle the whole time. But that's how so there's cutting depth based on the bit, and then there's also digital depth based on where you've done your touch off.
So I want to go ahead.
So you want it right above the material, just ever so slightly.
In this instance, I have it chucked up pretty darn close, but I'm not touching the material.
Yep.
Closer to the side cam. Well, I can't. And now I'm going to Z-touch. It's a real
I don't think the bit was.
I didn't tighten the collet.
Well, okay, here's tip number 11. Make sure you tighten the collet that the bit's in. See, this is great. We make mistakes. Everybody learns.
So I'm going to chuck that up there.
Yep.
Slightly, pretty much right next to the line that's engraved onto the bit.
Yep. And then when you put it in, it should bottom out on the workstation surface.
Yep. Touching
meaning
workstation.
You need to lift it up just a tiny bit, just ever so slightly.
Tight.
Yep.
And now we Z-touch.
And it should be like an instant Z-touch. And then the depth should allow you to go deeper. So you can always see what your max depth of cut is. It should be, right around 1.7 if you get the perfect amount.
Yeah.
Cool. So that's a couple of notes on that.
There we go.
10 tips.
11 tips.
11.
Some of the most common ones we see. If we missed one that you're like, hey, you got it. Talk about this. Please let us know in the comment section.
Maybe we'll do 10 more mistakes.
I mean, we definitely came up with,
We came up with
20
more.
things that we see often out in the world.
But we think these are the ones that, do the most good for everybody.
Yeah. Hopefully it was helpful for everyone. Thank you so much for watching. We will see you again in 2 weeks' time. Have a great night.